So first, just cover a few of the key factors of your DCM502. The first being that the setup and the measurements you're able to take with it. Standard, you have your flow sensor here, if you see the red highlight in the bottom right, to just validate that you do have flow through your sample cell. We have the ORP sensor on the far right. We have your pH sensor here. We have your free chlorine sensor and your total chlorine sensor. Additionally, you have the temperature sensor here on the bottom. Again, these are the standard readings that you're able to get from your prominent DCM502. The package itself comes exactly like you're seeing it here in the side picture. Panel mounted, pre-wired, set up, really ready to go. All you need to do is get it the sample water, and you're able to start controlling your pool once you plug in your oxidizer feed and your pH control feeds to it. Something you get when you have your free and total chlorine sensors giving you true parts per million readings. With those sensors, you're able to see a real-time combined chlorine reading. This reading is very beneficial, and we're going to go into some of the benefits and uses you have once you have that real-time water chemistry reading of your combined chlorines. Another feature you have is the remote communication ability, which is standard. If you look at the controller there, you can see right here where the red highlighter is, the Ethernet connection, where you're able to connect the standard Cat5 Ethernet cable to put it on a building's network, use a 3G modem, or a couple other options there that you have to be able to remotely view and monitor your pool readings, as well as change set points, clear alarms, have complete control over your controller from a distance and not have to be physically in front of it. Very useful tool, and if you need more information on that, we've covered that in other webinars that are available to view, and also you can contact your regional manager or local distributor for more information. One of the key features that we really enjoy with the DCM502 is the ability to do parts per million control with the ORP assist or ORP backup. One of the really the best ways that we think you should be controlling your pool water chemistry, especially when it comes to the amount of chlorine in your pool, because as everyone knows, you're getting tested on your parts per million of chlorine in the pool, not your ORP reading. While the ORP is a good reading and shows you how effective your chlorine's being in the pool water, it's not telling you truly how much chlorine there is. So with that feature, you're able to control to a set point using your free chlorine sensor. So you could have a set point of 2.0 parts per million, and it's going to hold it right there for you, controlling your oxidizer feed system. The ORP backup comes in when you put a low alarm on your ORP sensor, saying you never want to see it say below 700 millivolts, as an example. If for some reason you have the right amount of chlorine, but other conditions have changed and your ORP level drops below 700, it will ignore your parts per million sensor reading and feed until you're able to get that ORP reading above your low limit alarm. Once it is above that alarm, it'll go back to its parts per million control. Again, kind of giving you the best of both worlds. So you're sure not only do you have enough chlorine in your pool water, you also have the right amount of effectiveness or ORP reading from that chlorine reading. Again, really think it's the best way to truly control your pool water perfectly. Another feature it has is the ability to do programmable timed events. They can program to happen daily, once a week, once a month, and multiple different events. A lot of uses you can have there, anything from doing sensor washes to quite a few other events that you're able to set in there to happen. Really, the sky's the limit there when you're talking what features you're able to set up there. The controller itself is NSF50 certified. That's with all its sensors. Your pH, ORP, free and total chlorine sensors are all NSF50 certified to the most recent standards. Again, becoming more and more needed. Some states already require the controller to have NSF50, and with the upcoming Model Aquatic Health Code, really going to be the standard and needed on any pool equipment. So we already have that certification covered for you. Some of the other things not listed there, the ability to wire in multiple flow meters, so you can see flow at, say, different parts in your system. Water level control. You can do chemical tank level notification and be aware if your chlorine tank or your acid tank is low and needs refilled or changed out. Additionally, you're able to do PID control, which is just a more advanced way. Most people are familiar with your time modulated control for, say, your chlorine or acid feed to try and hold you at a more steady set point and not have such big over and under feeds. The PID takes that one step farther when you use it with the prominent concept pump or beta pump. You're able to actually change the speed at which that chemical feed pump is going, and that allows you to maintain your set point. It comes off the set point a little bit. It'll feed just a small amount of chemical to constantly try and maintain your set point and not have such big drops or overfeeds in, say, chlorine readings or your pH level. Again, that's just some of the basics of the DCM5 controller that we've covered there. And again, if you need more detail, feel free to contact us. The next piece I'll cover is our Dulcodes UV unit. It is a medium pressure UV unit, which is what here in the US that we've brought to the market, while our manufacturer is a low and medium pressure. We feel medium pressure is just a much better technology for generally what it's being used for in the US, which is your air quality improvement or your chloramine destruction, which in turn improves your air quality. One of the key features of our A unit is the set point controllability. And what you get with that set point controllability is the ability to not just select a power setting of, say, 50, 75, or 100 like many units. You're able to truly pick a reading you want to see your UV unit hold. So you can set up, once you've calibrated your UV sensor, you're able to set it up and based on your flow rate, size of unit, and the UVT or the transmittance of your water, basically how well the UV light goes through the water, you're able to select your set point, put it in there wherever you need it, 65%, 70%, 60, wherever, whatever number is needed, you're able to pick that set point. And once you have that set point selected, you're able to, the UV unit itself will do basically work like cruise control on a car. It's going to try to maintain that set point while using as little energy as possible. What this means is once you put in, say, 60% set point, the UV unit will go to full power, drop itself down to about 40% power, which is usually the lowest it'll be able to run and maintain the UV light on. And then it'll slowly ramp itself up how much power it's sending to the lamp until it hits that set point. Once it hits that set point, it'll constantly do slight adjustments to maintain this set point. This allows you to use as little energy as possible, but also maintain your set point based on other changes that may happen, whether it's water clarity, the quartz sleeves are a little bit dirty, the lamp starts to get a little older, the unit can send more power to the lamp to still ensure that you've maintained your set point. Really awesome ability there to be more efficient and to also, again, maintain the set point levels of whatever you're trying to do and the dose you're trying to hit. The next point, which I'll cover slightly here and more as we go, is the dual set point control. So now, instead of just having one all the time for chloramine destruction, I'd set the main one up at a disinfection level or the 400 joules per meter squared UV dosage, again, based on flow rate, size of the UV unit, and the UVT of the water. And it'll run at that power all the time. Again, uses less energy than when we would take it to the second set point, which would be our chloramine destruction set point of the 600 joules per meter squared. It would then go to that set point, operate there until, based on water chemistry, it comes back down. Again, at both those set points, it's operating like the single set point control and using as little power as possible, but to hit those set point levels. Another feature of our A unit UV is the electronic power supply. for just overall better energy efficiency. It transfers the energy to the lamp more efficiently than your standard magnetic ballast, which is what has traditionally been used in most UV units. Another point there is that UVA unit is NSF 50 certified and currently has its single pass validation for crypto deactivation is pending and will be done in the very, very near future. Just more certifications that are steadily being required by state, local, national codes, and soon to be required by the Model Aquatic Health Code once that moves forward. So again, those certifications will be all wrapped up before they're required across the country. A few other things to note that aren't listed on the bullet points there. You have the ability for, the unit itself has single end lamp connections, which you can see there in the picture in the bottom left. This is nice and maintenance friendly when it comes time to change the UV lamps. You only need access to one side of the chamber. It makes it a little more versatile as far as where you're installing it in a mechanical room. As we know, all nose space can be pretty limited when it comes to that. The other thing I'd like to touch on is what we call the True View visual indicator right here. This is on the back side of your UV chamber. And this is just a little O-ring there that when your UV light is on, as is the case in this picture, you get a nice green-yellow glow out of there. Again, just a visual indicator that your UV light and your UV lamps are on. Instead of relying, most of the time you can't actually tell 100% if it's on or not. You're relying on an indicator light on a control cabinet telling you, yes, it's on. But as far as you know, you have nothing guaranteeing that. This way, you know for sure that's glowing a nice bright green, it's on. When it's off, it's a dull white color. So again, when it comes to maintenance, just a kind of nice visual verification that your UV lamp is on. Now we'll move on to the next part here, which is why are we integrating these two pieces of equipment together? You have your DCM502, you have your UV unit. Each one is, very capable of running on its own just fine and doing exactly what you need it to do. I'm going to cover the benefits of why we want them to work together and talk to each other and the benefits it brings to the facility. So when we integrate these, we take our real-time combined chlorine reading, which we get from the difference of the free chlorine sensor and the total chlorine sensor. So if you have a free chlorine sensor reading of 2.0 and a total chlorine sensor reading of 2.3, you're going to see a combined chlorine reading of 0.3 in that example. So we can take that reading and alter how our UV unit is either set point running or on-off running to control it off real-time water chemistry. So as I have listed there, your first option would be simple on-off operation. It's going to be if the only reason you have UV is you're concerned with your air quality or your chloramine levels. So you want to run it when it's needed. You want to turn it off when it's not. Benefit of this is, you're only using or sending all that power to your UV unit when it's needed. So again, you're going to use less energy than standard running 24/7 operation of your UV lamp. Your unit would be off as standard once your combined chlorine reading went to an on set point level, which would say an example of 0.5 parts per million of combined chlorine. It would then turn the unit on. It would go to its set point, run in that single set point mode until it's driven those chloramines and the combined chlorine out of the water. Once it hits your offset point, the UV unit will go back to what we call a pause mode and sit there and be off until at which point the controller tells it it needs to turn back on because the combined chlorine levels have gone back up. Your other option for how to interface these two together is to use the dual set point control. I covered that a little bit earlier. Again, you'd have your primary set point would be a lower setting for your disinfection level. Again, it takes less UV light, therefore less power to do have a secondary disinfection. Really, the main thing you're looking at again is the deactivation of cryptosporidium or crypto. So we'd have it run all the time at that power. Once the combined chlorines got to your on set point, it could send a signal to the UV, which will then take it to a secondary set point, higher power setting, higher UV sensor reading setting that is going to be for your chloramine destruction. It would run at that level again until your chloramine levels went down. Once they're down, it'll go back to the disinfection level. You can see the screen here. This is a color change screen as far as when it comes to operation of the UV unit itself. You look at the bottom here, and you're able to see currently green means everything's good. If it goes to yellow, it's in a warning. If it goes to red, your unit's in fault. You can see this screen from quite a distance, so it's nice from an operation standpoint and knowing what status of the UV unit. A couple other things I'll touch on before we move on from this screen. You're able to see where your current UV intensity is. You can see it in watts per meter squared, or you can see it as a percentage, 80% out of 100. You can see it that way. You can see your primary set point, and additionally your secondary set point. Right here is the part where I was saying about how much power it's sending to the lamps, and you'll constantly see this number changing as it's trying to maintain that set point. Water quality changes and other items change. You're able to see that reading constantly changing. It's a good notification of quart sleeves being dirty or lamps aging or water quality changes. If your standard operation uses, in this example here, 1300 watts, and one day you come in and it's 8 months later and you're looking at it, maybe it's using 1500 watts now. Quart sleeve's a little dirtier, lamp's a little older, it's going to use a little more power. So just wanted to cover those items while I had this up on the screen. So then the benefits of doing those two methods of operation that I just mentioned, whether it's the on-off mode or the dual set point mode. You get your standard benefits of having a UV unit, which is your improved air quality by, again, getting rid of those mono chloramines, dichloramines, and nitrogen trichlorides, which cause that terrible chlorine odor in your swimming pools, the eye burn, the nose burn, really improve those. And then also the improved water quality when you're talking the parts per million control, which is very efficient and excellent way to control your water as far as your disinfection levels. And then your UV units also, again, to keep the combined chlorines out of the water and also to be there for that second layer of disinfection. Again, the energy savings you're going to see versus standard UV operation are huge. Not only does it have the electronic power supplies for the lamps, which are more energy efficient than traditional magnetic ballasts, but you're also doing these two methods of operation that are going to help you save energy on top of the set point control. So set point control is more efficient than just running at 100% power all the time. And then whether we're turning it on and off, obviously if it's off half the time because the water chemistry doesn't deem it necessary to be on, you're going to see huge power savings there. Or if you have it all the time at a lower power disinfection level and only up higher when you need it, again, more power savings. Another area where you're going to save versus traditional operation of a medium pressure UV unit is chemical savings. We've done studies and we've noticed that when you run a medium pressure UV unit at your 600 joules per meter squared UV dosage, you see approximately, in the ballpark of around 20% of your good free chlorine is actually getting burned off by your UV unit. It's an innocent bystander in this situation. It's part of the UV light attacking those combined chlorines. It's hitting a little bit of your good chlorine. So if you run your unit 24/7 at this level, you're going to see a slight increase in daily use of your chlorine. Now, the ability for our unit to either turn on and off when used with the chemical controller or to go down to that disinfection level until it needs to go after the combined chlorines. When you run at that disinfection level, you're not burning off your good chlorine. It's a very nominal value, if any, is actually being hit. So now you still have the disinfection, secondary disinfection help there without hitting any of your good chlorine. So again, chemical savings over your standard operation of a medium pressure UV unit. The other benefit of these two methods of operation are extended lamp life. Again, you're not working the UV unit as often or as hard, so you're going to extend the lamp life. And everyone knows, the lamps are, basically you're planning once a year to spend, $1,000 plus, depending on the size of your unit, how many lamps it has. This can be a good additional, cost savings for the end user. And finally, another benefit is just having one manufacturer for both pieces of equipment. As far as I know, we're the only manufacturer out there prominent that has both the chemical controller, giving you true parts per million readings, free total, pH, ORP, and then using that in turn with our UV unit to help assist that piece of equipment operate even better. They were designed together, and they're designed to operate together. And when it comes to anything as far as service, then also, again, you have one person, one distributor, or one supplier to call for assistance on anything you may need, parts, lamps, pieces, for anything. Again, that one person just makes life a little easier. So now I'm going to take you to just a little bit of a walkthrough on what you see on the remote interface when it comes to the remote interface of the DCM502. A little bit about what it looks like here as I've pulled it up on the screen, and what it looks like when you're doing UV control with this chemical controller. So let's see if I'm still logged in here, if I need to. Yeah, my password has expired. So you always need a password, and you can do multiple passwords for different operators, so you're able to track who's changing what set points. And I'm going to highlight just a couple areas, the basics of this remote interface. Here in the top right, you're able to change the name of the pool. You're able to see what kind of controller you have, whether or not you have any alarms. Go down your main area here, which are your sensor readings, which you have your pH sensor, your ORP sensor, free chlorine sensor, total chlorine sensor, your combined chlorine reading, and this one right here is your sample cell verification that you have flow through your sample cell. One thing I'll point out while we're looking at it, you can see the continuous time counter here. 11.39 hours is telling you that it has had flow on it for 11.39 hours. And we're just a little bit after 11 o'clock. You haven't lost flow through your sample cell all day. If you were to come in and this would say off, such as if you look over here at the acid tank one, it's been off for 11.4 hours. So that's been off all day. If they had changed status at any point, the counter is going to reset, so you would know, if on the flow one here, if it only said 2 hours, I would know that 2 hours ago I lost flow at some point through my sample cell. Just a good way to kind of know what's happening with your system even when you weren't watching it. As we continue on the other items you see here on the home screen, you can see your acid feeder. You can see if it's on or off. Again, acid tank level. Look, as we're looking at there, it just turned on for a little bit. It's on time-based modulation, and then it'll turn off here shortly. Again, you can see that counter counting up as well as how long it's been on. Just some really neat features here. You can see your oxidant feed, your oxidant tank, so going to be your chlorine tank if you have a booster pump. In this example, you can see your temperature sensor getting a reading, and this controller would be controlling the heater. So you're able to see the heater's been on the full amount of time, as this temperature sensor's reading pretty low versus a standard pool, obviously. And no, this isn't connected to a pool, if you were wondering. It's just sitting on a wall right now. Over here on the left, you can see your flow meters. They're able to wire in multiple flow meters, so you can see your flow rates. Surge tank level sensor would be here. That would then in turn control a fill valve to help maintain our water level control. So again, that was just wanted to touch on some basics that you see there. Now we'll focus a little more down here on our input. Here would be actually a signal coming from our UV unit telling me what my current UV sensor reading is. That way I can see that remotely as well. So I even know where my sensor reading is at the time. And then this set.6 UV control is going to be what I'm going to use to either turn on or off my UV unit, or do the dual set points and switch between set points. The signal is a simple low voltage, small signal, no concerns there as far as what you're running from the controller to the UV unit itself. So if I click on this UV control, you can see I'm currently in automatic control mode. I'm controlling off H, which over here is my combined chlorine reading. You can see on set point at 0.5 and off at 0.1. So that's telling us it won't turn on until it hits 0.5. Once it gets all the way down to 0.1, it's going to turn off until the level goes back up. So to simulate this, I'm just going to, again, because there's no water through this system, I'm going to take my total chlorine sensor. And when I click on it, again, you're seeing how easy it is to navigate with this remote monitoring system. And I'm going to just recalibrate it so it's going to give me a high enough reading that it says, I need to turn on now. So I'm going to tell it my total chlorine reading is 2.4. All right, so now we have a 0.7 difference. As you can see, the combined chlorine reading changed and has since turned on my UV control output. Again, this is now going to send a signal to my UV. It's either going to turn it on if it was off, or it's going to take it to that higher power mode, higher UV sensor setting. So it's able to ramp up its power and hit those combined chlorines. Again, once it drives those combined chlorines back down, and I'm going to simulate this by recalibrating the sensor. Now back down, so now I've gotten rid of all my combined chlorines, recalibrated at 0 combined chlorine, and that is now turned off. Again, just showing you how that would happen in real pool water. Obviously, the time frame would take a little longer, but you're able to see a little simulation there of how it would work. Again, very simple, and the benefits your facility gets by interfacing these two together. Again, from the energy and chemical savings on top of the benefits that each piece of equipment gives you on its own, from the parts per million control of the controller to the chloramine destruction ability and the greatly improved air quality from a medium pressure UV unit, really makes just so much sense to me to interface these two together. So that's really, again, basics of what I have. We're going to open it up to some questions now, and that can be typed in, and Jim will read them over to me.
Yes, thanks, Dustin. So you can see, as Dustin mentioned, both of those units are very good units on their own, each being independent of one another. But I think, combining them, that it really is a very powerful tool for us. The DCM5 is very versatile. You can program it for different inputs, different outputs, as we're aware. And that the UV unit, the Dulcodes A, it can, maybe interact on very simple. It has its own control panel, and that panel is what wires to the DCM5. But if the customer just wants the UV unit for the interim to make it change between the standard disinfection mode and the deactivation of the smell, if they have the bad odors and the eye burning, they can just jump up to the higher range with a simple toggle switch as well. So we can make it as easy or as automated as the customer wants with those devices. So one question here: are you at all concerned about the lifespan of the bulb by turning off and on?
No, because it's not going to be something, it's going to be off for several hours. It's not like your water chemistry is not going to change quick enough in one day that the unit, is going to turn on 5-6 times a day. That's not an area I'd be concerned with. Generally you'll see it only once or twice a day max, I would say. Especially, if it's a really busy facility. Obviously the UV unit only runs once the combined chlorines go up. Once they go up, and if your facility's packed all day, UV units only see or are only able to treat the chloramines that they get to see. So it's limited by the turnover rate of your pool. So in that situation, it's probably going to run most of the day at a really busy pool, even into the night as it catches up. Once it gets all caught up and the pool's finally quit creating those chloramines due to the large amount of bather load, then you probably see middle of the night it's going to turn off until some point later in the day. Once your pool activities pick back up and you've increased your bather load, and now you have a combined chlorine reading again.
And that unit, the control panel for the UV system, it does closely monitor how the bulb is powered up and how it is shut down. So it's not a simple on-off lamp, I should say. I get corrected all the time for that, so please excuse me there. But it monitors how that lamp is powered on and powered off. So it does take precautions for that. You do change the power levels maybe during that operational period, but while it's powered on, it pretty much remains on, like Dustin said, until it's not needed any longer.